A previous video introduced the distributive property. The distributive property states that for all real numbers a, b, and c, c times the quantity a plus b equals ca plus cb. Now that you've already had some time to explore that in a previous video, let's take a look at why this actually works. Let's take a look at some evidence that this actually works. In a previous video, we worked out the following problem. 3 times the quantity x plus 2. We applied the distributive property and figured out that it was equal to 3 times x plus 6. Now, most people who aren't into advanced mathematics or even into algebra couldn't really look at these two expressions, the first one and the last one, and say, yeah, those two look equal. That's not very obvious. So let's take a look at a method that might make it a little bit more obvious, or give us evidence that it is indeed, that this is indeed equal to this. So here's what we're trying to show. We're trying to see whether 3x plus 2 is indeed equal to, so we're checking, 3x plus 6. Because when I simplified, what I'm saying is that as I go from each step to the next step, I'm not changing the value. Well, what I'm going to do to test this is I'm going to pick a value for x. And no matter what value I pick for x, once I simplify the left side and I simplify the right side, and this 3x plus 2 should be in parentheses here. Once I simplify both the left side and the right side, they should be the same. So let's pick a value for x. So what I'm going to do is I'm going to go ahead and let x equal 5. Now, x could have been anything. This isn't, when we started over here, this wasn't an equation to solve. We don't know what x was equal to. We're just being very general here. So what I'm going to do is I'm going to pick any value. I could have picked any value I wanted to. I decided to pick 5. Now I'm going to substitute in 5 to see if both sides remain the same. So I'm going to substitute in for x 5. And I'm going to see if that, when it's simplified, equals the same thing as when I simplify this, when I plug in 5 for x. So here we go. The left-hand expression, I'm going to simplify it following the order of operations. There's no, well, I guess there was a given value for the variable. We already substituted it in. There's no subtraction, that's step 2. Step 3, do everything inside the grouping symbols. We can do what's inside these grouping symbols. 5 plus 2 is 7. Bring everything else straight down. There are no powers, but there is multiplication. 3 times 7 is 21. We've got the expression down to one number, so that's in simplest form. We want to see if that equals what we get when we simplify the right-hand expression. We've already substituted the given value in for the variable. There's no subtraction. There's no grouping symbols with any operations inside. There are no powers, but there is multiplication, so I should do this 3 times 5, which is 15. Bring down the plus 6, and now I do all addition and subtraction from left to right. 15 plus 6 is 21. So here, 21 is equal to 21, so yes, both of these expressions are equal to each other. So this shows us evidence that when I follow this distributive property method, I don't actually change the value of the expression. Now I encourage you to try this very thing. Try to see if you can pick a different value for x. Maybe try x equals 7 or x equals 10. Make sure that what you get on both sides is the same. The distributive property can also be useful for performing mental math calculations. For instance, if you want to multiply 2 times 53. Now you could possibly do this in your head in a number of different ways, but here's what you need to understand. If you understand place value, if you understand that 3 is just 3 units, and the 5 here, since it's in the tens place, is 5 tens, 5 times 10. Here's what we get. 2 times the quantity. This 5, since it's in the tens place, represents, we could say, 50 plus 3. Now, we multiply. We can use the distributive property to multiply 2 times 50, which is 100. And then we bring down the plus sign. And then we multiply 2 by 3, which is 6. And 100 plus 6 is 106. Now, this needs to happen in your head if it's going to help you with mental math. Now, you might look at this work here and say, wait a minute, that looks very complicated. You can do this quite easily in your head. Just by looking here at the 2 times 53. Think, 2 times 50, well 2 times 50 is 100, 2 times 3 is 6, 100 plus 6 is 106. All I did is went through this process in my head. Let's try another one. Let's consider 3 times 74. So the first thing I need to do is take 3 times 70. Well, I know that 3 times 7 is 21, so 3 times 70 is 210. 210, then I need to add 3 times 4. 3 times 4 is 12, so I'm going to add 210 with 12, and in my head I can get 222. Now, let's see if this works if I actually write in the steps. This is 3 times 70 plus 4. 3 times 70, 210, plus 3 times 4, 12. 210 plus 12, 222. Now this will take practice, but once you get good at it, it'll make multiplying these kinds of numbers in your head much easier. So distributive property has use in algebra, so it allows us to go through the order of operations more effectively, but it also has applications to mental math.